Hi, all. About 8 hours to game time. Go Boston. Okay, folks, this is my latest fun stuff. I'm trying to count the number of 4-digit numbers in base 10 that's equal to a corresponding 4-digit number in base 7. You know, that's what this horizontal bar connotes. The horizontal bar is sometimes called the Vinculum, I think. And it's a way to say that these are 4-digit numbers. Otherwise, you might think it meant A times B times C times D. In other words, when you see letters juxtaposed, you think that means multiplication. But these are 4-digit numbers. This is a 4-digit number in base 7, and this is a 4-digit number in base 10. Okay, now here's exactly what it means. Okay, base 10 is a positional number system where you multiply the digits times corresponding powers of the base, and that's exactly what happened here. A minus 3 times 10 to the third, B minus 6 times 10 squared, 10 times C, and then D plus 6 is technically times 10 to the 0. Now, in a similar fashion, this base 7 number, which is what this 7 means, positionally is it's A times 7 cubed plus B times 7 squared, and so on, okay? So what we can do if you subtract this right-hand side, this RHS, okay, from the left-hand side, you end up with this statement right here. Now, so I did leave out some of the steps, but just so you believe me, notice that you would have 10,000A on this side, right? 10 cubed times A is 10,000A. And on this side, you would have 7 cubed, which is 343A. If you subtract 343 from 1,000, you get 657. Okay, so that's where the 657 came from. So I literally subtracted this term from this term right here. Now, you'll also see you get 1,000, you get 600. That would have been negative on this side of the equation. That makes it positive on this side of the equation. So again, it's not too difficult to go through it. I just didn't want to clutter the screen with the extra work. So we get this statement. Now, what can we already say about things? Well, we can say for sure that A can't be equal to 6. Okay. For a fact, let me see if I get the pen to work here. A does not equal 6. See, we're already getting some constraints here. So that's 6. Okay, A does not equal 6. And you guys can see if 6 was in this position, 6 times 657 certainly exceeds 3,600, right? No matter what happens with B, C, B and C. Okay, so A cannot equal to 6, and y'all remember a base 7 number has only 0, 1, 2, 3, 4, 5, and 6 as its permissible digits. That's base 7. In base 10, the permissible digits are 0, 1, 2, 3, all the way up to 9, right? So again, base 7, 6 is the largest digit, just like 9 is the largest digit in base 10. Okay, so we've already eliminated 6 as a possibility just from this statement that has 3 unknowns in it. All right. So now the rest of this work is just cranking out the arithmetic. We just said that A couldn't be equal to 6, and it can't be any less than 5 either. And that's not too hard to see. If you tried 4, right here, you're getting a number far less than 3,000. And the rest of these numbers aren't going to make up the ground. They're too small, right? So this all implies that A is equal to 5. I could be slightly more formal about this, but I think it's getting the point across. So A is equal to 5. We know that for a fact. And also a similar type of analysis down here, and you guys can verify. I just substituted the 5 right here. You can see I replaced A with 5. And after all the arithmetic happens, we find out that B is equal to 6 and C is equal to 1. But we still don't know what D is, okay? And that's a little disconcerting. And that's what this next line does. We just substitute all these numbers in, do the arithmetic. And let me clear out this screen and let's run to the next page here. Y'all remember 5, 6, and 1 are equal to A, B, and C. I couldn't keep everything on the same page. So again, A is 5, B is 6, C is 1. Let's go to the next page. I got to get rid of my pen, I guess. Okay, on to the next page. Okay, y'all, here we are. On to the next page. Now, what's a little odd about this is that since D plus, let's go back. You may be wondering where all these numbers come from. Let me just go back to the next screen. Notice that D plus 6 right here cannot exceed 9, right? D plus 6 cannot exceed 9. 9 is the biggest digit you can have in base 10. So D plus 6 has to be less than or equal to 9. Okay, so let's move along here. Not sure why the screen is not in. Okay, so this would be the case where D is equal to 0. Okay. You would get 2016 base 10 is equal to 5610 base 7. This would be the case where D is equal to 1. D equals to 2, and finally D is equal to 3. So there's actually 4 possibilities, which is kind of strange when you say solve. I didn't know how to word it that well, but there's actually 4 possibilities where the bases hold and they're equal to the same number. So this is 1 possibility, this is 2 possibilities, this is 3 possibilities, and this is the 4th possibility. So again, I probably could have done better right here by saying find all possible solutions. So I just called it solve and discovered that there was actually 4 digit numbers in both base 10 and base 7 where we had equality. Hope you liked it, folks. Let me know. Go Boston.